It has been a year since the release of the first amazing images from the James Webb Space Telescope. And to celebrate, NASA is showing us something new. Welcome back to Techstination. I'm Fred Fishkin. And with us are from NASA, astrophysicist Taylor Hutchison. Hi, Taylor.
Hi.
And from Princeton University, professor, author, and astrophotographer Bob Vanderbei. Hi, Bob.
Hello.
Well, for those of you watching, not just listening, we'll start out with this brand new image from the Webb Space Telescope. Taylor, tell us about it.
Yeah, this image is just exquisite. So what you're looking at here is this star-forming region. That's the closest one to where we live. And the really beautiful thing about this is, first of all, just as a nerd, I love the crispness and the detail that you can see in this image. This really speaks to the power of the JWST. But for the more science part of it, what you're seeing here is essentially there's about 50 young stars inside of the star-forming region. And the dark regions that you see are these very thick columns of gas and dust that are kind of enshrouding these baby stars that are still forming. And then you'll see these horizontal and vertical jets that kind of look like lava. They're like glowing red. These are regions that are actually what we call molecular hydrogen jets. And they're actually young stars that are forming and shooting out this molecular gas. And then my favorite part of this whole image is the very bottom corner. And you see this really bright, kind of white looking region. And this is actually a star that's really close to the size of our sun, just a little bit bigger. And it's forming and actually kind of blowing out the gas that's around it. And so it's kind of creating this bubble that you can kind of see there. And so all together, you're seeing this very chaotic, awesome star forming system.
Exciting. Bob, your thoughts about this new image?
Yeah, so it's beautiful, first of all. It's just amazing. I've been looking at Hubble pictures for many years and Webb pictures for a year. And I've been taking my own pictures for many years. And they're all beautiful. But I have to say, this Rho Ophiuchi one that I just looked at for the first time this morning has got my heart pumping the hardest of all of them. It's beautiful and it's interesting. I downloaded the 135 megabyte full file to look at it, because when you look at it, it's 12,000 by 12,000 pixels. So just on a computer screen, you're not really seeing the details that you can see if you download the whole image. And it's just amazing. It's beautiful and it's interesting. And there's that double star in the upper left where one of the stars is bluish and the other star is reddish, and they're almost on top of each other. But the diffraction spikes are amazing. But I did have one question for you. The circumstellar disks, I couldn't quite tell exactly. Is that the big area around that whitish area, or are we talking about something smaller and more subtle to see?
Yeah, that's a great question. So those will be smaller and also kind of different kinds of light you'd need to see to really see that in great detail. But for the baby stars that are forming inside of the really dark regions in this image, if we could peer through that, so using even redder light or even larger wavelengths, you could start to maybe peer in and see the circumstellar disks around these baby stars that are forming.
Yeah, yeah.
And Taylor, I understand we may be seeing in this image some planetary systems in the making?
Potentially, yeah. So whenever a star forms, it's kind of, I like to think of it as like a whirlpool of matter that's kind of infalling on this forming star. And in that process, the circumstellar disk that Bob mentioned, you're also having planets form at the same time. Not all of them will survive the process. It's because it's a very messy, chaotic process. But that is also when you should have most of your planets form around a star at the same time.
Taylor, tell us a bit about your journey leading you to NASA, and fairly recent, I think, and how exciting this is for you.
Yeah, so I started out, I'm from Texas, and I kind of fell into love with astronomy only when I got to college, actually. There was a tiny observatory on my tiny liberal arts university campus, and I started working there and helping out some of our amateur astronomers who were taking astrophotography, and kind of fell in love from there. And then I did graduate school at Texas A&M University, and then got to learn about what the JWST was, and then we were all waiting like with bated breath for when this telescope would launch. And then I got my first post-PhD job as a NASA postdoctoral fellow, and so now I get to work on this all day, and it's awesome.
What a place to land! Not bad. So,
yeah.
What have been some of the highlights of what we've learned during this first year of Webb? It's been a time machine of sorts.
Yeah, it's been wild. I mean, so NASA had these 4 science goals that were the things that we were expecting to be able to do with this telescope, right? You know, it's very specific things. My favorite one is trying to find the most distant galaxies that we possibly can. That's the kind of science that I work on. And so the really exciting part is JWST, even in this first year, has begun to do that. We began to answer a lot of questions that we were hoping for because this observatory is amazing. But there's also things that we're finding that, you know, we weren't expecting the sensitivity of this telescope to be able to do. And so we're finding even more distant galaxies than we were even hoping for, and like with exquisite resolution and sensitivity. And it really is kind of mind-blowing how amazing this observatory is. I mean, we already knew it was a feat of engineering, but it really is kind of continuing to be very much worth all of the effort that went into it.
And Bob, I know this has been an exciting year for you, first year of Webb.
Yes, it's very, very exciting. And I like the cosmology part of it, but I also wonder about detecting exoplanets and the atmospheres, and are we going to determine if they're, you know, if they're Earth-like planets and stuff. Is there much been going on in that direction, or how's that?
Yeah, so that's actually one of the other science cases of the 4 that I mentioned. That's one of the other ones that we're really focused on, is trying to find and characterize the exoplanets that we can find using this telescope, but even more specifically, look at their atmospheres, like you mentioned. And that's the really cool part. You can look at the molecules in the atmosphere using a thing called spectroscopy, which is kind of like a light fingerprint. And from that, you can really pick apart, okay, what's going on inside this planet? And if you see particular biosignatures or molecules that really indicate this really couldn't come from anywhere except for life, that could be really exciting. But then you can also kind of pick apart, okay, what kind of rain do we have on this planet? Is it water or is it something else? You know, or what is yeah, what are the winds and the weather patterns? And you can really start to understand this using this observatory.
Yeah, it'd be really fun to discover new stuff in that direction.
Yeah.
Taylor, let me ask you, this is, I suppose, a bit nerve-wracking, at least to us amateurs, when you read about it, the concern about dust and rocks. I think there was early on some damage from a micrometeoroid.
Yeah.
And I guess this is all out of your hands. I mean, it's up there and there's nothing you can do to protect it, right?
Yeah. Unfortunately, we do not yet have the technology to go there and fix things. So whatever happens out there, we have to work around. And so actually what you mentioned with these micrometeoroids, there's more out there at L2 than I think we were anticipating, because now we just have a better, more sensitive telescope out there. And so actually what's happened in the science community is we now point at different places in the universe that are not in the stream, essentially, the flow of these micrometeoroids. And so that's one of the ways we've tried to fix this, is like, okay, we're not going to look directly into the fire hose. We're going to look away from it, and that'll protect our mirrors a little bit better.
If the mirror doesn't break, it just gets a little ding. That's not a big deal.
Yeah, like ideally we'd have no dings, but yeah, a little ding is much better than like a broken mirror. So
well, this is really, I mean, a year in, and we're just getting started, right? So tell us about what the hopes are, what the future may hold for what Webb is going to deliver for us.
Yeah, so for my field, again, that particular like most distant galaxies, the thing that we're wanting to do is just continue to push the limits. How far back in time can we see? And what can we really understand about these incredibly distant galaxies? You know, we have the ability with this amazing observatory to understand the chemistry inside of these galaxies and what kind of stars live inside of them. Are they the size of our sun? Are they much more massive? Where are the black holes, if they exist in these galaxies? You know, kind of really understanding how these first galaxies formed and evolved, and kind of connect that to, you know, where are we today? Like, how did our galaxy get to the way that it is? And we really will be able to answer this using this observatory. And this next year will make massive strides towards that.
Are we learning things about our own planet in the process here?
I think so. I think especially with the work being done studying the other planets in our solar system, I mean, the more that you learn about the other planets that formed in the same system that our planet formed in, the more we can really come to understand what's going on in our own system. And it's really fascinating to see. I don't know if y'all seen these beautiful images of Saturn and all of the other big gas giants in our own solar system, but they're just exquisite. And the details that you can see, we really will start to build an even better picture of what's going on with this telescope.
So exciting. And for more info, where can people go, Taylor?
Thank you. Yeah, jwst.nasa.gov is the place to go for all of the info. But if you want to just have like a nice, like constant stream of pretty pictures, you can go to Twitter and Instagram, and I think a few other platforms. And NASA Web, 2Bs at the end, is the handle for the account for this particular observatory. So go follow all of those.
Well, congratulations on the work being done there. Just terrific. And congratulations on your career. Taylor Hutchison, thank you for spending time with us.
Thank you so much. This was really fun.
So, Bob, after listening to Taylor and knowing what's been accomplished over the last year, what are some things, and I think you kind of hinted at it, that you'd like to see explored here?
Yeah, so exoplanets and how many planets are similar to Earth out in the universe is a very interesting question to me. And of course, the even more interesting question, but less likely to be answered question is there intelligent life out there? And I do have the opinion that there probably is, but there's billions and billions of galaxies and billions of stars within each galaxy, and every star probably has most every star has planets. And so how many Earth-like planets are out there is probably billions and billions. And is there intelligent life? Probably, but these things are all so far away. We can't travel a billion, or even a million light years in our lifetime. We can't even travel 1 light year in our lifetime. So the chance of us interacting with these intelligent beings is pretty much zero. But knowing if they're out there would be really, really interesting, because I can have a thought that they're out there, but to actually find out that they're out there by detecting atmospheres around planets, around some of these stars, that JWST is going to be improving that sort of technology advances. And so that'll be really interesting. I'm looking forward to that.
And people can see your work that you do essentially right from home as well. They can get a glimpse of some of your wonderful astrophotography online and in books as well.
Yeah, I love it. I started doing astrophotography 20 some years ago, and I just do it from my driveway here a little bit north of Princeton. And the technology has just evolved so amazingly, even for Earth-based telescopes that even amateurs can afford to buy. I mean, my telescope equipment is not cheap, but it's less than the cost of a car. And a
little less than Webb too, right?
A little bit less than Webb. And it's just amazing what you can do with this equipment. It's really fun, and it's interesting, and it's beautiful, and yeah, I love it.
And the latest book is called Welcome to the Universe in 3D, that you are co-author of with Neil deGrasse Tyson, who's that guy, yeah. Michael Strauss, and J. Richard Gott, right?
That's correct. 4 of us, yeah. That was fun to work on, and it's been a fun project, yeah.
More in the offing?
Maybe. We'll see how it goes. There's more discussion. So can't give you anything definite right now, but I hope so.
Something to look forward to. Bob Vanderbei, thank you for spending time with us as well.
Yeah, thank you very much.